Okay, next, try naman natin i-solve yung uniformly varying load. Okay, uniformly varying load. So for this one, again, compute for the reaction. So we have here the summation of moment at point B is equal to 0, counterclockwise positive. Okay, so we have here RA, negative RA, multiplied by 3 meters. Tapos yung ating load dito sa taas, i-convert lang natin into its equivalent concentrated load by having its area. So the area is 1/2 by 6 by 3. Okay, 1/2. So plus 1/2 of 6 by 3. Yung ating moment arm is from this point sa kanyang centroid papunta dito. So that is 2/3. 2/3 of 3 meters. Okay, 2/3 of 3 meters is equal to 0. Therefore, the reaction at A is equal to, cancel out yan. So we have here, cancel out din yan, 18 divided by 3, so 6. Okay, so 6 kilonewton. Double check natin, baka mamaya pumalya tayo dito. Plus 0.5 of 6 by 3, tapos 2/3 of 3 is equal to 0. Okay, so we have here 6 kilonewton. And then for the reaction at B, summation of forces vertical is equal to 0, upward positive. So RA plus RB minus 1/2 of 6 by 3 is equal to 0. RA is 6 kilonewton. Therefore, RB is equal to, so we have 1/2, 6 by 3, 9, ayan na. So we have 6 plus X minus, okay, may trust issue na. So we have here RB is equal to 3 kilonewton. Kasi this is 1/2 of 6 by 3, so 9. Tapos 6 yan, so tama, 3 kilonewton. Double check lang natin para sure, no? Kasi nasa reaction tayo. Okay. So for this one, we will now create a section. Okay? I-erase na natin ito. So you need to master the basic kasi para dun sa mga succeeding examples natin, pag pinaghalo-halo ko na yung mga load, hindi kayo malito. Okay, so we have here AA. So for this one, isa-set aside natin yung nasa left portion. Maganda siguro pag maglapis na tayo dito. Okay. So ang magiging illustration is para po siyang, kasi nag-cut tayo dyan, parang magiging trapezoid. Okay? This is, yung RA natin is 6 kilonewton. This is 6 kilonewton and then this is the distance X. Okay? So, dito po natin makikita yung shear at AB and then of course yung moment at AB. Okay. So, alam natin na this is equal to 6 kilonewton per meter pero hindi po natin alam yung value nito. Okay, kung saan tayo nag-cut. Diba? Kasi nag-cut ka dyan eh. Anywhere, po pwede kang mag-cut dyan pero you need to identify kung ano yung value nito. Tawagin natin yang Y. Okay? What is the value of this one? So, Y. So, for identifying yung ating value ng Y, kailangan natin ng ratio and proportion. Okay? So, kumbaga, sige, dito ko i-drawing. Kumbaga, dito tayo nag-cut, diba? Ayan. Dito ka nag-cut. So, iyan yung Y. So, paano natin na-identify yung Y? By ratio and proportion. Okay? So, by ratio and proportion, we have here 6 by 3 is equal to Y by, ano ba to? Since nag-cut tayo dito ng X, di ba? X po yan. This is already 3 minus X. Right? X tapos 3 minus X. So, we have 6 all over 3 is equal to Y all over 3 minus X. Therefore, what is the value of Y? Y is equal to 2 multiplied by 3 minus X. 2, 3 minus X. Therefore, in other words, Y is equal to 6 minus 2X. Okay, so the value of this Y now is equal to 6 minus 2X. So, ibig sabihin, we can use this equation, no, in identifying the value of this cutting section here. Kasi kahit nag-cut ka dito, for example, kahit nag-cut ka dyan, applicable pa rin yung equation na to. Okay, kung nag-cut ka dito, applicable pa rin yung equation na to. Bakit? Kasi, naka-X po siya. Yung Y, nakadepende po yung value niya sa X. So, kahit ilipat natin yung mga section, yung exploratory section natin, same pa rin po yung gagamitin natin na equation. Because the y, nakadepende po siya dun sa x. Okay, yung y nakadepende sa x. Okay, so for this one, since alam na natin yung value ng ating y, 6 minus 2x, ready na po tayo to determine the resisting forces here. So we have here, shear at AB is equal to 6 upward. Okay? Tapos, meron po tayo ditong trapezoid. Pwede natin kunin yung full trapezoid po dito as the concentrated load. Pwede rin po natin hatiin. Okay? Sa akin kasi, I prefer na hinahati na po siya para dun sa moment mamaya wala akong problema. Okay? Hatiin natin siya. So, kumbaga, dalawang shape. Uunahin ko yung rectangular muna. So, this is equal to, ano ba to? That is equal to, tama. This is equal to 6 kilonewton per meter. Yung, sige, lagyan natin dito. This is 6 minus 2x na, no? Kasi yan yung y, 6 minus 2x. Tapos ito is the distance x. Yan. Okay. Dito naman, ano na yung value natin dito? So, the value of this one is 6 minus 2x. Okay? 6 minus 2x. Or in other words, we have 2x. Tama? Distribute mo yung negative sign. So, magka-cancel yung 6. We are left with 2x. Okay. So, the value of this one is 2x. So, unahin muna natin yung rectangular. So, 6 minus, kumbaga kukunin natin yung equivalent na concentrated load ng ating rectangular loading. Yung dating rectangular load, okay? Yung dating rectangular load, kunin natin yung equivalent na concentrated load, okay? So we have here yung area minus 6 minus 2x by x. Okay? Tapos isunod naman natin yung triangular loading dito sa taas. So, triangular po siya. Kunin natin yung equivalent na concentrated load. So, the equivalent concentrated load is the area minus 1/2. This one is 2x, and then we have here length of x. Okay? So, just a review, no? We have here 6 kilonewton. Tapos, ito naman yung area ng ating rectangular loading. So, meron tayong 6 minus 2x multiplied by x. Tapos, yung isa, rectangular or triangular loading, kunin mo lang area ng triangle. So, we have 1/2. Tapos, ang natira dito is 2x, and then we have here the length of x. Okay? So, simplify na lang po natin. 6 minus 6x plus 2x squared. Am I right? 6 minus 6x plus 2x squared. Okay, and then cancel out yan. Minus x squared. Okay. Therefore, we have here x squared minus 6x plus 6. X squared minus 6x plus 6. Okay. So, this is now the resisting shear at segment AB. And then, for the moment, okay, moment na po tayo. We will take the summation of moment here. So, we have 6 kilonewton multiplied by x clockwise motion. Pero, again, na-transpose na po kasi natin siya kaya clockwise. Positive. Okay. So, 6x next. Yung ating rectangular loading naman. Okay. Kaya ko hinati yung trapezoid into rectangle and triangle kasi mahihirapan akong mag-determine ng moment arm pag trapezoid yung ginamit ko. Okay? Pwede naman na i-consider nyo siya as a whole. Wala pong problema doon. Okay? Kunin mo yung equivalent concentrated load nito. Pero, ako kasi hindi ako masyadong familiar dun sa location ng centroid if meron po tayong trapezoid. Kaya ang ginagawa ko is hinahati ko siya into two shape kasi alam ko yung centroid ng rectangle and at the same time, I know the centroid of the triangle. Bakit kailangan natin yung centroid? Kasi yun po yung reference natin for the moment arm. Okay? Sige. So dito, sunod natin yung ating rectangle. Magmo-moment po tayo dito. So kunin natin yung area. Kung baga kokopihin mo lang to eh. Ito yung force eh. Ito yung force. Ang kailangan mo lang idagdag is yung distance para magkaroon ka ng moment, di ba? Ito yung force. Kailangan mo lang ng distance. Kagaya nito, ito yung force. Ano yung distance? X. Okay? Ganito rin dito. Minus 6 minus 2x by x. Yan yung force. Ano yung distance ngayon? Kasi ito yung ating equivalent concentrated load. Diyan nag-act. Ano yung moment arm mo ngayon? Ito yung kalahati ng x, which is x all over 2. Okay? X all over 2. And then, the next one, we have here minus 1/2 of 2x by x. Ito na po yung force. Ang kailangan natin is the moment arm. Okay? Nasa triangle na po tayo. Yan yung concentrated load. Kailangan ko ng distance from this point papunta doon, which is, okay? Yan yung kanyang equivalent concentrated load. Ano yung distance na to? According to Mechanics 101, this is 2/3 of the length. Diba? Ano ba yung length natin? X. Okay? Tapos, pag ito naman yung reference mo, that is 1/3 of X. Okay? So, the moment arm is 2/3 of X. Okay? Then, simplify na lang po natin. We have here 6x minus, okay, magiging x squared all over 2 po yan. And then, i-distribute po natin. Minus 6x squared all over 2 plus 2x of x squared all over 2. Tama ba? 6x squared all over 2 plus 2x squared all over 2. Okay. Minus, cancel out yan. Okay. Combining like terms. So, meron tayo ditong 2/3 of x cube. Okay, double check. 1, 2, 3, x cube, and then 2/3. Okay. And then, simplify pa natin. This one is already 3. Tapos, ito, cancel out, x cube din to. So, naging x cube na po yan. Okay? Therefore, we have here 2/3. So, 1 minus 2/3, 1/3. So, we have here x cube all over 3. Ayan. Kinombine ko na po to. So, 1 minus 2/3 is 1/3 of x cube. Okay na po tayo dyan. And then, x squared. Meron pa po tayo dito natira na 3x squared. So, minus 3x squared. Tapos, another one here plus 6x. Okay? X cube all over 3. Double check po natin. Minus 3x squared. Tapos dito, cancel out. X cube na po yan. Okay, 6x. So, ito na po yung ating shear equation and then moment equation. Okay. So, it's time now to identify yung ating, or i-drawing po natin yung shear and moment equation. Okay? Now, shear and moment diagram, I should say. Okay? Okay, so this is for the shear diagram and then moment diagram. So here, for our segment AB, distance po natin dito is 0 to 3 meters. Okay, 0 to 3 meters. So at point A, substitute lang natin yung x with 0. So we are left with 6. Okay, 6. Positive. Okay, sa taas. And then next one, for point B, substitute x with 3. So we have here 3 squared minus 6 of 3. Tama. Ay, tama. So we have x squared minus 6x plus 6, 3. So we have here negative 3. Negative 3 kilonewton. Okay? Negative 3. So we have here negative 3, tapos meron tayong 3, negative 3 kilonewton, positive 3. So maglo-close yung ating shear diagram. Okay, now, take note of this illustration. Okay, kasi iba po yung magiging illustration natin if we have a triangular loading. So for this one, take note of this. If the loading diagram is increasing, the shear diagram will concave downward. Okay? If the loading diagram is increasing, the shear diagram will concave downward. This is for shear diagram. Okay? And vice versa, if the loading diagram is decreasing, the shear diagram will concave upward. Okay, so anong ibig sabihin nun? So we have here the diagram. So yung loading diagram po natin is decreasing. So according to this note dito, if the loading diagram is decreasing, the shear diagram will concave upward. Okay? If the loading diagram is decreasing, the shear diagram will concave upward. So ano po yung magiging itsura nun? Okay. Decreasing yung load natin kasi from 6 napunta siya ng 0. So paano natin i-connect yung 6 to 3 ngayon? So kailangan natin ng curvature. Kasi take note, this is already considered as 1 degree. Okay? Considered na po to as 1 degree curve. So ano ba yung susunod sa 1 degree according to our last topic? That is a 2 degree curve, di ba? Meron tayong 0 degree. 0 degree curve is a horizontal line. Tapos next to it is a straight line. Kaso nga lang may slope. 1 degree po yun. Ang susunod sa 1 degree is a line na may curvature na. Okay? So that is considered as 2 degrees. Pero yung curvature natin, dalawa kasi yan, is either pa ganito or pa ganyan. Ito yung tinatawag natin na concave downward, tapos concave upward. Okay? Yan po yung ating degree of curve. So for this one, since decreasing po siya, now the shear diagram will concave upward. So the line na gagamitin natin dito is concave upward. Okay? Naka-concave po siya upward. Yung bending po niya is on the upward or dun sa facing up. Okay? Ito po yung tinatawag natin na concave upward. So this is now considered as a 2 degree curve, and then of course yan 2 degree curve. Kasi pag hindi natin alam itong notation na to, po pwede na yung magiging illustration mo is pag ganito, di ba? Ayan. Which is hindi po siya or hindi niya nasusunod yung binigay nating notation ngayon. So you need to take note of this one, guys. If the loading diagram is decreasing, the shear diagram will concave upward. So, paano naman pag ganito? Okay, pabaliktad. So, imbis na ganyan yung ating, imbis na ganito na yung ating magiging diagram. Okay. Of course, we will have here the shear diagram. So, ano ba yung value? Parang babaliktad rin lang natin siya. So, ang magiging value mo dito is still 3. RB is, of course, 3. Tapos dito, we have 6. Okay? Kaso nga lang, nandito yung 3 mo ngayon. Tapos, nandito naman yung 6. Okay? So, paano mo i-connect yung 2 dots ngayon? The load diagram is increasing. Therefore, it must concave downward. Okay? Downward. So, yan yung difference ng concave upward and concave downward. Okay? Next. Since alam na po natin yung para sa shear diagram, proceed naman tayo sa moment diagram. Okay? So, identify muna natin yung points here. So, at point at AB. So, by using this equation, we have x cube. At x is equal to 0, malamang 0. Okay. So, at x is equal to 0, moment is also 0. Next, at x is equal to 3, the moment is equal to x cube all over 3. Minus 3x squared plus 6x. Calculate x is equal to 3. Okay, 0 also. Okay. Baka tanungin ninyo, ma'am, kukonect ba namin yan diretso? Hindi po. Okay. Kasi take note, meron po tayong tinatawag dito na point of zero shear. Okay. Point of zero shear. Ang ibig sabihin, 0 yung shear or value ng shear dito sa point na to kasi intersection na po yan, di ba? This is 0, positive, negative. So as you can see here, nasa alignment po siya ng 0. Therefore, considered siya as point of zero shear. So at point of zero shear, take note of this one. At point of zero shear, the maximum bending moment, the maximum bending moment occurs. Okay, at point of zero shear, the maximum bending moment occurs at the point of zero shear. Okay, ano daw? Yung English ko Okay, at point of zero shear, the maximum bending moment occurs. Okay, ayan. At point of zero shear, the maximum bending moment occurs. It's either positive or negative bending moment. Okay? So for this one, kailangan po natin i-project yan. Ibig sabihin, nandito po yung peak ng curve natin. Okay? Kasi mayroon tayong point of zero shear. So how to identify yung value ng moment dito sa part na to? Okay? Yan yung peak So for this one, ang gagawin lang natin is we will use the shear equation. Kasi kailangan natin i-identify kung anong exact location yan. So, sabihin natin x. Ano yung distance x na yan? Because at distance x, dito po natin makikita yung point of zero shear. Okay, so by using the shear equation here, so we have x squared minus 6x plus 6. Okay, point of zero shear, ibig sabihin yung shear, tawagin natin A prime. Okay? So, yung shear at A prime is equal to 0. Di ba? So, by using this equation, x squared minus 6x plus 6 is equal to 0. Para ma-identify natin yung distance na x na yan. Okay? So, the distance x is equal to 1.2679 meters. Okay? So, at 1.2679 meters, dyan po nag-a-occur yung point of zero shear. Therefore, paano natin yan i-compute yung moment dito? Okay? Ito kasi yung peak Ano yung gagamitin natin equation? So, we will use the moment equation. Ito po yun. On which, kunin natin yung moment at A prime is equal to x cubed all over 3 minus 3x squared plus 6x. And then, we will substitute x with 1.2679. Okay, we will substitute x with 1.279. Therefore, the moment at A prime is equal to x cubed all over 3 minus 3x squared plus 6x. X is equal to 1.2679. Ayan na pala. So, we have 3.464 kilonewton dot meter. Okay. So, 3.464. Positive. 3.464. Okay? So, ito po yung peak ng ating moment diagram. So, take note at point of zero shear, the maximum bending moment occurs. Dito po natin makikita yung peak doon sa point of zero shear. So, matik, pag meron kang point of zero shear, kunin mo yung distance para ma-identify mo yung value ng moment. Okay? So, paano naman ngayon natin i-connect yung mga dots na to? So, meron tayong notation dito para sa shear diagram. Meron din po tayong notation para sa moment diagram. Okay? So, ilagay natin dito. Sige. So, for our moment diagram, guys, moment diagram. Okay. If, ang basis na po natin ngayon is the shear diagram, no? Kanina, yung basis natin sa shear diagram is yung loading. Ngayon naman, ang basis na po natin is the shear diagram. So, if the shear diagram is increasing, okay, the moment diagram will concave upward. Okay? Concave upward. And if the shear diagram is decreasing, moment diagram, ano ba yan? Tingnan na lang ng maayos. If the shear diagram is decreasing, moment diagram will concave downward. Okay? For our moment diagram, guys, if the shear diagram is increasing, the moment diagram will concave upward. And if the shear diagram is decreasing, moment diagram will concave downward. So, paano naman yan? Okay, let's take a look at this shear diagram. So, yung shear diagram po natin dito is decreasing, di ba? Kasi from 0, napunta siya ng, from 6, napunta siya ng 0. So, decreasing. So, since decreasing, okay, if the shear diagram is increasing, it will concave upward. If the shear diagram is decreasing, it will concave downward. Okay, so shear diagram is decreasing. Therefore, this illustration will concave downward. Ayan, ganyan po, concave downward. And then from 0, napunta siya ng -3, still decreasing. Okay, decreasing pa rin siya. So still, it will concave downward. Okay, concave downward. So makikita nyo, meron siyang curvature na it faces downward. Kasi, madali lang i-identify kasi if naka-upward or downward yung curve mo. Okay, so this is in downward curve. Okay, so since 2 degree yan, ang susunod sa 2 degree is a 3 degree curve. Okay, so you need to make the curvature visible para malaman natin kung concave downward or upward. Okay, ganyan. So we have here 3 degrees. Okay, so ito po yung peak Ibig sabihin yan yung highest point. Okay, so yan po yung magiging moment diagram natin. So that is for the triangle or triangular loading. Okay, so since we are already done with the basic, meron na po tayo for concentrated load. Example for concentrated load, meron na din po tayong rectangular loading, and then we have a uniformly varying load. Therefore, ready na po tayo yung combination po nung lahat ng ating loadings, type of loadings. Okay, combination of loadings. So let's proceed now to the next example. Okay, so we have here simple beam, and then combination of concentrated load and uniformly varying load. Okay, so ganun pa rin, our first step here is to identify yung magiging reaction. So this is A, B, C, D, and E. So this is reaction at A, reaction at E. Okay, so let's take the summation of moment at point E is equal to 0 counterclockwise positive. So we have negative RA multiplied by moment arm 4, 5, 6. So 6. Next, minus or plus, I should say plus 8 kilonewton, moment arms 2, 3, 4. Okay, and then this one we have plus 4 kilonewton per meter. Length is 2 meters, tapos yung moment arm is 1 meter plus 1 meter. Okay? So just a review if meron tayo ditong uniformly distributed load, again, you need to convert yung kanyang kunin mo yung equivalent na concentrated load, and then you need to identify the centroid para malaman natin kung anong magiging moment arm. Okay? So area, so we have 4 multiplied by 2, tapos yung moment arm is 1 plus 1. Okay? Is equal to 0. Therefore, the reaction at A is equal to 8 kilonewton. Double check natin kasi mahirap na pag nagkamali. So we have the negative 8x, 6. 2, 4, 6. Negative 6x plus 8 of 4 plus 4, 2, 1 plus 1 is equal to 0. Okay, so the reaction is equal to 8. And then, summation of forces vertical is equal to 0. Upward positive, we have RA plus RE minus 8 minus 4 by 2 is equal to 0. RA is 8. Therefore, RE is equal to, cancel out yan, also equal to 8 kilonewton. Tama? Kasi magka-cancel out yan, we are left with 8. Transpose po natin 8 kilonewton. Okay. So, 8 kilonewton, 8 kilonewton. And then, identify na po natin yung section. So, for this one, we will be having 4 exploratory lines. So, A, B, C, and D. Okay. So, for AA, kulin natin yung nasa left. This is 8 kilonewton. Distance X. Tapos, meron po tayo ditong shear at segment AB, and then of course yung moment at AB. Okay. Shear at AB, so shear at AB is equal to 8 kilonewton. And then for moment at AB, we have, take the moment here, 8x kilonewton per meter. Okay? So ito na po yung shear and moment equation for segment AB. Next, for BB, distance x, then meron na po tayo ditong 8 kilonewton. This is distance 2 meters, x minus 2. So nandito na po yung ating shear at segment BC and then moment BC. Okay? So for the shear at BC, taking the summation of the forces, so vertical nung nasa left side, so we have here 8 minus 8 is equal to 0. And then moment BC, take the moment here, we have 8 multiplied by x. Tapos we have here minus 8 of x minus 2. So simplify lang po natin. We have 8x minus 8x plus 16 cancel out. So the moment BC is 16 kilonewton per meter. Okay? So ito na po yung shear and moment equations for segment BC. And then next, let's proceed to segment CC. Okay. Segment CC, 8 kilonewton, 8, and then yung ating uniformly distributed load. So this is 4 kilonewton per meter. Distances, distance x, so this is 2 meters, 1, and this is x minus 3. Okay? So dito yung shear at segment CD and moment at CD. Okay. So the shear at CD is equal to 8 minus 8. Tapos ito, we have minus 4 by x minus 3. Okay, and then simplify po natin. We are left with negative 4x plus 12 kilonewton. Okay, so that is the shear at segment CD. And then for the moment, we have 8. Moment arm is x. Next, this one, minus 8. Moment arm is x minus 3 plus 1, or also x minus 2. Okay, x minus 2. And then ito naman for the uniformly distributed load, minus 4 of x minus 3. Ano yung moment arm? From this point, centroid, papunta dito. That is x minus 3 divided by 2. Okay? So simplify, we have here 8x minus 8x plus 16. Cancel out. Magiging 2. So minus 2. And then, combine na po natin yan. X squared minus 6x plus 9. Okay? X squared minus 6x plus 9. Okay, so combining like terms, we now have negative 2x squared. Cancel out na po yan. Negative 2x squared plus 12x. Tapos meron tayo ditong 16. 16. Tapos distribute natin yan. Minus 18. So negative 2. Okay? So ito na po yung para sa moment equation ng segment CD. Okay? And the next one, let's proceed to the last segment, which is for DE. Okay? DD. So, ganun ulit. Paulit-ulit lang po yung magiging process natin dito, guys. 8 kilonewton. So, it is 4 kilonewton per meter. Distances na po tayo. This is 2 meters, 1 meter, 2 meters, and then x minus 4, 5. Distance x. Okay? So this is now the shear at segment DE and then moment at DE. Okay? So huwag kayong malito dito sa mga tawag dito, direction ko Kahit mali naman yung direction ko dito, ang magre-prevail pa rin is yung equation. Okay? Kaya nga tayo nag-set na ng equation para kahit anong ilagay mo dyan na orientation, makakorek na with the use of our equation here. Okay? So we have here, shear at DE is equal to 8 minus 8. Tapos ito, meron tayong minus 4 by 2. Okay, 4 by 2. So, cancel out. Cancel out, we are left with negative 8. Okay, so the shear at segment DE is negative 8 kilonewton. And then this one, we have here for the moment at DE. So 8x. Next, dito naman, minus 8. Moment arm is x minus 2. And x minus 2. Tapos this one, minus 4 by 2. Moment arm is kalahati dito, papunta dyan. So we have 1 plus x minus 5. Okay? 1 plus x minus 5. Okay? And then simplify natin. So we have 8x minus 8x plus 16 minus, ano ba yan? This is now x minus 4. Okay? So minus 8x plus 32. Tama? Kasi 8 yan. 8, okay. 8x, negative 8x plus 32. So cancel, cancel. We are left with negative 8x plus 48. Okay? Negative 8x plus 48. Moment at DE. Okay? So this is now the shear and moment equation for segment DE. Okay? So plot na po natin yung ating diagram. Okay, so for our shear diagram, at segment A, okay, point A, 8 kilonewton. Point B is also 8 kilonewton. So, positive 8, positive 8. Okay, connect the dot na po natin. Connect the dots para hindi po tayo magkalituhan mamaya. So, we have here 8. Ayan, straight line. Next, the shear at segment B, C. So we have at point B, 0. At point C is also 0. So from 8, napunta siya ng 0. Okay? And then at point C, also 0. Okay? And then next, at segment DE na po tayo, or segment CD. Ayan, CD. So dito, ano yung gagamitin natin na dimension or length? Kasi meron na po tayong X. Okay? Nasa CD tayo, CD. So we will be using 3 to 5. Okay? 3 meters to 5 meters. 3 meters to 5 meters. And then, dito na rin, tuloy na natin for segment DE, 5 meters papuntang 6 meters. Okay? Sige, dito sa AA, 0 meter to 2 meters. Segment BB, 2 meters to 3 meters. Okay. Sige, substitute na po natin yung value dito. So, negative, so the shear at point C is equal to negative 4x plus 12. Ano yung x mo? 3. So, we have 0. And then, for point D, we will be using 5. So, negative 8. Okay? So, point C is 0. Point D, negative 8. Okay, negative 8. Okay. So, this is a 0-degree curve. So, tama lang na straight line yung magkoconnect sa kanila. And that is now 1-degree curve. Next, last segment na po tayo. So, at the point D, we have negative 8 kilonewton. Negative 8 kilonewton. Tapos, at point E, we also have negative 8 kilonewton. Okay? So, point D, negative 8. Point E is also negative 8. And then, connect the dots. So, negative 8. Ano yung reaction at E natin? 8 kilonewton. So, negative 8 plus 8, 0. Okay? So, ito na po yung ating shear diagram. Okay? Shear diagram. So, it is very advisable to use straight edges. Okay? And then, next, let's proceed now to the moment diagram. So, for our moment diagram, at point A, okay, moment at point A, ang x po natin is 0. So, 0 moment. And then, for point B, 8 by 2. So, we have 16 kilonewton that meter positive. So, 16 from this point, papunta dito. So, 16. Okay, next, moment at BC. So, moment at B is also 16. Moment at C is 16. So, tama na equal sila, di ba? 16. So at B, we have here 16. Tapos C, also, tama ba? Moment at B is 16. Wait lang guys. So we have here moment at B. Double check po natin ha. So 8x minus 8 of x minus 2. 8x minus 8x plus 16. So cancel. We are left with 16. So moment at B is 16. And then moment at C, point C, is also 16. Okay. 16. Okay. Next, moment at point C ulit. Dito na po tayo. Moment at point C. So we have negative 2x squared plus 12x minus 2. Ang x po natin, since nasa C po tayo, is 3. So dapat lang na 16 yung makuha natin dyan. Ayan. Also 16. And then moment at point D, ang x naman natin ngayon is 5. So we have here 8. Okay, so from 16, napunta po siya ng 8. Dito. So meron here, 8. And then, 8 kilonewton that meter. Tapos, moment at point D na po tayo. Last segment na. So negative 8x plus 48. X is 5. So dapat 8 yung makuha natin dyan. Tama. 8 kilonewton that meter. And then moment at point E, ang x natin is 6. Okay. So 0. So 8 tapos napunta po ng 0. And nag-close yung ating moment diagram. So it's time now to connect the dots. Okay. So from this one, 0 degree curve yan. Okay. Ay, wait lang po. Moment at A is 0. Okay. Moment at A is 0. Ayan, okay. 0. Okay, 0, 0. Tapos, napunta ng moment at B is 16. Okay. So, this is nagtaka kasi ako kasi 0 degree yan. Tapos, 16 pa dyan. Parang may mali. Okay. Kasi dapat 1 degree curve yung mag-recreate natin dito. Diba? So, from 0 to 16, this is a 0 degree curve. So, ang kailangan lang natin is a straight line. Okay. 1 degree curve. And the next, straight line lang po yan. Okay. So, 0 degree. Okay. Ito na po yung application nung gaya kanina. So, just a review, no? If the loading diagram is increasing, the shear diagram will concave downward. Okay. But if the loading diagram is decreasing, the shear diagram will concave upward. Okay? And then, sa shear diagram naman, if the shear diagram is increasing, the moment diagram will concave upward. And if the shear diagram is decreasing, the moment diagram will concave downward. Okay? So, dito, yung shear diagram po natin is decreasing, di ba? From 0 napuntang negative 8. So, decreasing po siya. Decreasing. Therefore, ang magiging orientation ng curve natin is pababa. Okay? Pababa. Masyadong mataas yung lagay natin point. Lagay natin dito. Okay. Kasi kalahati ng 16. Okay? So, ang orientation ng curve mo is pababa. Kasi decreasing. The shear diagram is decreasing. The moment diagram will concave downward. So, ganito po yung itsura ng magiging curve natin. Pababa. Ayan. Concave downward. Visible naman siguro na concave downward yan. Okay. Concave downward. And then, 2 degree curve yan. And then, 0 degree kasi yan. So, straight line lang dito. Straight line. 1 degree curve. Okay? So, ito na po yung ating moment diagram. Okay? Moment diagram.